This is a short presentation on good programming structure in C++, or getting things in the right sequence for our program. First, we'll have a review. There are 5 lines of code that we will use in every single program that we write for this class. We'll have our libraries, which include all the pound includes, in this case iostream.h. Then we'll have int main void with an open squiggly to begin the program, and we'll finish with a return 0 and close squiggly. Now, what we're talking about today is how do we sequence things inside the squiggly brackets. So for good programming structure, the first thing we'll do inside the squiggly brackets is declare variables at the beginning of the program. In other words, we have to set up all the memory and variable names that we need to make our program work. The second place we'll have to consider is an input section. This is where we get key information input to the program so that we have it available for other steps that may need that information. Next, we have a calculation section. Once we have variables and values for key variables that we can get from the keyboard, we can then use that information to calculate other values in the program. After that, we have our output section. We can't output results until we've declared variables, input key values for key variables, done our calculations, and then use the output section to see out our results. All the while, inside the squigglies, we also want to focus on using good variable names so that not only is our program sequenced correctly, but it will read very well and we'll understand the problem when we look at our program at a later time. Okay, let's look at an example. Let's say that we have opened a program and we're ready to declare variables. For example, let's say we have variables A, B, and C, and what we want to do is input A and B. First, we declare variables, and then we do our cout and cin statements to get values for A and B. We'll add a calculation section to practice our modulus operation. C is equal to A modulus B. What we want is the remainder after we try to divide A by B. Now we're ready for the output section where we see out the results. We can place the values for A, B, and C on the screen because we now have the ability to recall all from memory. So let's do a quick recap here. We have variables declared. We have 3 integers, A, B, and C. We have an input section where we get the key values we need for A and B. We then have a calculation section where we find the value of C. And then we have an output section where we output A, B, and C. Then we could look at how we might consider intuitive variable names. This is simply a program to demonstrate a capability. Most of the time, we will be looking at solving a specific problem. For example, intuitive variable names basically mean we have variables that sound like what we were modeling. For example, let's say that we want to find the area of a rectangle when we know the length and width. One way we could write this is area equals length times width, where we have used an actual variable name that corresponds exactly to the way we would talk about the problem. So I would use variables for area, length, and width. We would declare them float area, float length, float width, probably do cin statements to get length and width, and then we have a calculation, area equals length times width. Okay, here are some examples of what not to do. Product equals A times B, or X is equal to Y times Z, will do the same thing mathematically, but they don't represent the program or the problem we're trying to solve. Area equals length times width sounds exactly the way we would talk about finding the area of a rectangle. Therefore, they are superior variable names. The ones shown in pink at the bottom simply would not do. Think of it this way. You might write a program this month and not use it again for another 6, 8, 10, 12 months. When you open that program and you want to remember what you were thinking when you wrote that program, intuitive variable names will help you do that very efficiently. Okay, let's go use what we learned as we develop new programs.